Hello dear students, hope all are doing fine. Today I'll be starting with the chapter Binomial Theorem. This chapter was there in the deleted portion and this is a very important and the easiest chapter. Okay, here one big derivation is there, but I'm not going to explain that derivation. As we know, the theory exams have been cancelled, so we'll be concentrating only on the competitive part. So what I'll do is, first I'll explain all the concepts based on this theorem. Then we'll be solving, once it is done, we'll be solving a MCQs on this binomial theorem. Okay, let us start with this one. See, this binomial theorem is mainly based on the expansions. You have studied about a plus b whole square, a plus b whole cube, those expansions, right? So those expansions can be written by using these theorems. For example, if I consider a plus b whole to the power 0, what will be the value? 1. Right? A to the power 0 will be 1. Now, if I consider a plus b whole to the power 1 will be equal to a plus b. Right? And here this 0, 1 is called index. Now, if we consider a plus b whole square, what will be the value? Expansion will be a square plus 2ab plus b square. Right? Even this is a known expansion. Now, if I consider a plus b whole cube, expansion will be a cube plus 3a square b plus 3ab square plus b cube. Even this is a known expansion. Right? Now, if I want to find a plus b whole to the power 4, how to find this? We can multiply a plus b whole square twice, right? So that will get a plus b whole to the power 4. But now I am not going to write the expansion of this. We'll see it later. Now, here the main thing you have to observe, first thing is, see here to the index will be 0 and the number of terms is 1. Here you can see index is 1, number of terms are 2. 1, 2. Here index is 2 and number of terms are 3. See, 1, 2, 3. Here index is 3. So we have to get the number of terms as 4. We can see here 1, 2, 3, 4. So this is the first observation. The thing is, whatever the index will be there, the number of terms will be 1 more than the index. If I consider a plus b whole to the power 95, so the number of terms should be 96. This is the first observation. Okay. And the second observation is, here you can see the power of a is goes on decreasing and power of b is goes on increasing. Agree? Right? A square, a to the power 1, a to the power 0. Here b to the power 0, b to the power 1, b to the power 2. That means the power of a will be goes on decreasing and power of b will be goes on increasing. Right? See here, a cube, then square, a to the power 1, a to the power 0. A is decreased. Power of b is b to the power 0, b to the power 1, b to the power 2 and b to the power 3 is nothing but power of b is increased. So this is the second observation. Now, see here, a plus b whole to the power 4. As I told you, to write this one, I can write a to the power 4, right? Then plus a to the power, we have to decrease the power of a, so will be 3 and b to the power, here it was 0, it will be 1, right? Plus next will be a square and b square plus a to the power 1 and b cube, right? Plus b to the power 4, right? A plus b whole to the power 4. Now here this is the 4. Index is 4. So number of terms should be 5. We'll count. 1, 2, 3, 4, 5. Right? Is it correct? The expansion of this one, is it equal to this one? This, the power of increasing a and, decreasing a and increasing b is correct. But what about their coefficients? We have not written the coefficients. Here coefficients will be there. Right? So, by this one, we can write the powers of a and b, but not the coefficients. But to find the coefficients, we'll be using one method that is called Pascal's triangle law. by using this law, we can write even the coefficients. Let us see that. What is that Pascal's triangle? Here I'll write index, okay, and here I'll be writing the coefficients. See, in the first one, what is the index? 0. What is the coefficient? 1. Right? Coefficient is 1. Second one, the index is 1. What are the coefficients? A to the coefficient is 1, B to the coefficient is 1. So 1 and 1. Okay? Square. So index is 2. So coefficients A square, that is coefficient is 1. AB coefficient is 2, right? And B square coefficient is 1. I hope you are getting this. Now cube. What is the coefficients now? What are the coefficients? A cube coefficient is 1. Agree? A square B coefficient is 3. Right? AB square coefficient is 3. And B cube coefficient is 1. See, there is one condition. See, you can see here 1 plus 1 will be 2. Right? First and last terms are 1. Other than that, see here 1 plus 2 will be 3. Right? And 2 plus 1 will be 3. Now I want to write the index for the fourth one. Can you? What I have to do? First we have to start with 1. 1 plus 3 will be 4. Right? 3 plus 3 will be 6. 3 plus 1, 4 and 1. Now just we have to add this. This is 1. Next is 4. Right? Then will be 6. Then will be 4 and then will be 4. Now if I want to fifth one, what it will be? 1. 1 plus 4 will be 5. 4 plus 6 will be 10. 6 plus 4 will be 10. 4 plus 1, 5 and 1. Yes? Now if I want to find the sixth one, what it will be? 1 will be as it is 1 and 5, 6, 5 and 10, 15, right? 10 and 10, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6 and 1. Count the number of terms. Here index is 6. So the number of terms should be 7. 1, 2, 3, 4, 5, 6, 7. Right? So this is called the Pascal's triangle. But in the competitive exams, we will be not using this method. We will be using the binomial expansion. That is different. Just you should know this concept. Okay. So this is 6. So what it is? Always remember, if I want to find A plus B whole to the power 8. So the number of terms will be 1 more than the index will be 9. Then to write the expansion, power of A should be decreased and power of B should be increased. Now, if I want to find the A plus B whole to the power something 72. Okay. Now, to find this A plus B whole to the power 72, and even that is not easy because there will be 73 terms, right? It is difficult. Still, to find that till 71, I have to write to get the coefficients, right? Then only I will get the 72. So, even that will be very lengthy, right? 1, 2, 3, 4, 5, 6 like that till 71 I have to write. Then the 72nd will be this expansion. Even that is lengthy. So, instead of going for this Pascal's method, we will be using another method, that is the binomial theorem. Simple. See here, this is the index is 0, right? And this 1 can be written as 0, C, 0. I'll explain, okay? 1 is this. So, this is 1, C, 1. Sorry, 1, C, 0 and 1, C, 1. So, similarly, here 2 is there. So, this value is 2C0. What is meant by C? 2C0 if I say, this is a combination. You have studied NCR formula, right? So, this is NCR will be equal to n factorial divided by n minus r factorial into r factorial by using a permutation and combination. Here this is the combination. By using the binomial expansion, directly we can write. See here, this is 4 is there. This will be 4C0, okay? And this is 4C1. You can check the value. This is 4C2 and this will be 4C3 and this will be 4C4. Now, here the index is 6. So, what I have to do? I have to start with the 6. It will be 0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. Like that we can write. Okay. I'll explain that binomial expansion. First I'll erase this one. Don't worry about that Pascal's triangles and all. Just we'll see the expansion. So the binomial expansion says that a plus b whole to the power n. Okay. A and b are any integers or the rational numbers. N is an integer. A plus b whole to the power n will be equal to nc0. Okay, as I told you, 6 means 6c0, 6c1, 6c2, like that. Here it is n. So nc0. Then you have to decrease the power of a and increase the power of b. So a to the power n, okay, and b to the power 0 plus next term will be nc1, a to the power, here it is n, we have to decrease means it will be n minus 1, or else what we can write, n minus 1, and b to the power increasing will be this one, 1. Okay, you have to remember this formula. This is like a formula, plus nc2, a to the power n minus 2, okay, and b square. Like this we have to expand till the last value will be ncn. What is the a to the power? Can you? A to the power n minus n will be 0 and b to the power n. So this is called the binomial expansion. Very important formula. Okay. This expansion is proved by using a mathematical induction. As I told you, I am not going to explain that. Just you have to remember this formula. Okay. For example, see, we will use the same thing to write a plus b whole square. You know this formula, but still, just for the verification. A plus b whole square, 2, right? So it will be 2c0, a to the power 2 minus 0 will be 2, and b to the power 0, plus next 2c1, a to the power 2 minus 1 will be 1, b to the power 1. Yes, expansion same. So this will be 2c2, a to the power 2 minus 2 will be 0, and b square. Yes, so what is 2c0? 1, right? A square, b to the power 0 will be 1, plus 2c1 is 2. How to find this? 2 factorial divided by 2 minus 1 factorial into 1 factorial. A to the power 1 and b to the power 1. Plus 2c2 is 1. Sorry, a to the power this should be 0, right? See here, a square 1, 0. B to the power 0, 1, 2. And this is this. So this is called the expansion. Okay. So this is a plus b whole to the power n. Is it clear? The thing is a plus b whole to the power n will be equal to, these are called the binomial coefficients. Start with nc0, nc1, nc2, nc3, nc4 till ncn. Okay. And power of a you have to decrease and power of b we have to increase. Simply what we can write this as, see, a plus b whole to the power n can be written as summation, okay, n, this one, n c k, a to the power n minus, summation is sum of the terms, n minus k, and b to the power k, and the value of k is varies from 0 to n, or this expansion. This is a simple form of that. Is it clear? So this is a plus b whole to the power n. Now based on this expansion, we will see some more expansions. Yeah, a plus b whole to the power n. Now if I want to find a minus b whole to the power n, what we can do? The value of a is a and the value of b is replaced by minus. So this can be written as a plus minus b whole to the power n. Can we write like this? Both are same, right? Yes. Whole to the power n. Now see, the simple it is. Here the b is replaced by minus b. So we'll expand in that. That will be nc0. What we are going to do? A is a itself, but b is replaced by minus b. Yes, we'll do nc0, a a to the power n, anyway b to the power 0 will be 1 plus nc1 a to the power n minus 1 and the value of b will be equal to minus b. Is it clear? See, this is the expansion form a plus b whole to the power n. Now we are finding for a minus b whole to the power n. Next will be plus nc2 a to the power n minus 2 and b is now minus b whole square plus like this. The last term will be ncn a to the power 0 and minus b whole to the power n. Yes. Now by this what we can write? Actually the board is very small, so it's a little difficult for me. Okay, fine. See here, nc0 a to the power n, nc0 a to the power n. What happens here? Minus b. So this will be minus nc1 a to the power n minus 1 b. Next term will be minus b whole square. Obviously it will be positive, right? See here b to the power 0 is there, b to the power 1 will be negative, b square, even number, so it will be positive. Next will be minus because you will get b cube, right? Next will be b to the power 4, so we will get positive, then b to the power 5, so negative. So the simple thing is, whatever may be the expansion, a minus b whole to the power n, this everything will be same. First sign will be plus, then minus, plus, minus, plus, minus. So alternate signs you have to write. So that means by a plus b whole to the power, so a minus b whole to the power n will be equal to nc0 a to the power n minus nc1 a to the power n minus 1 b plus minus, then plus nc2 a to the power n minus 2 b square. So like this it goes, plus ncn b to the power n. Is it clear? Just the thing is, you have to remember the expansion of a plus b whole to the power n is this one. Okay, if you want to find a minus b whole to the power n, listen carefully, the expansion of a plus b whole to the power n is this one. If you want to find a minus b whole to the power n, the expansion will be same, but you have to change the alternate signs. I mean, first it will be plus, then minus, plus, minus, plus, minus. Is it clear? For example, if you want to find a minus b whole to the power 3, okay? So the signs will be, first it will be positive. How many terms will be there? 3 means number of terms are 4. So first it will be plus, then minus, plus, minus. If it is number of terms are 5, one more plus will be. Like that, okay? So this is about the expansion. A plus b whole to the power n and a minus b whole to the power n. We'll see some more. I have written both the expansions, a plus b whole to the power n and a minus b whole to the power n. In a particular case, if I write the value of a is equal to 1 and the value of b is equal to x, okay, in this one we'll be replacing a by 1 and b is equal to x, and this will be now a is 1 plus b will be x whole to the power n, and this is a formula important, okay, this formula is important for the objectives. Now 1 plus x whole to the power n will be nc0, a is 1, 1 to the power n will be 1, right, plus nc1, again here 1 to the power n minus 1, so we are not going to write that, b will be x, plus, can you next term, nc2, and power of 1 will be decreasing. Anyway, power of 1 is increasing or decreasing, doesn't matter, it will be 1. So nc2 power of x will be increasing, x square. So the last term will be ncn x to the power n. Is it clear? So this is the important expansion. 1 plus x whole to the power n is equal to nc0 plus nc1x plus nc2x square till ncn x to the power n. One more case, if I write x is equal to 1. Now what happens? 1 plus x is 1. So 1 plus 1 whole to the power n will be equal to nc0, right, plus nc1, again x is 1, plus NC2, x is 1, last term will be NCn. So that means 1 plus 1 will be 2 to the power n. This you have studied in the combinations, right? 1 plus 1 will be 2 to the power n is equal to formula NC0 plus NC1 plus NC2. So the last term will be NCn. This is about the expansions. Okay, important expansions. Remember this: first, second, third and fourth. These 4 expansions you have to remember. Okay, just remember this. Now we'll see the general terms. Now we'll see about general terms. Very important one. How to find the general term. And there is a one formula to find this. Okay. Now you can see this is the n is how many terms should be there? As I told you, n means the number of terms will be 1 more than that. So n plus 1 number of terms are there, right? If it is the index is 4, the number of terms will be 5. So here the index is n, so number of terms will be n plus 1. Remember. Now the first term, what is the first term? First term you can see here NC0 a to the power n, right? In the expansion, first term is this one. What is the second term? Second term will be NC1 a to the power n minus 1 and b, right? So this is the second term. So similarly, can you say what will be the rth term? See this. 1 is there, NC0 less than a to the power n and b to the power 0. Second is there, NC1 a to the power n minus 1 b to the power 1. So similarly, the rth term will be, yes, n c 1 less than this, right? So r minus 1 a to the power n minus of r minus 1, right? N minus of r minus 1 and b to the power r minus 1. So this is nothing but NC r minus 1 a to the power n minus r plus 1 and b to the power r minus 1. This term is little lengthy and doesn't look good, right? So instead of finding the rth term, we'll find the r plus 1th term. Okay. Now can you say what is the r plus 1th term? R plus 1th term. See, n c 1 less than that. Here r plus 1 is there. Less means NCR, right? R plus 1 minus 1. So plus 1 and minus 1 will get cancelled. NCR a to the power n minus r and b to the power r. So this is called the general term. Okay, general term, very important. You have to remember this formula. This is like a formula. So general term is represented by T r plus 1. Okay, T r plus 1th term is given by, remember, T r plus 1 is equal to N C r. In the expansion of, this is very important, you have to see which expansion, a plus b whole to the power n, a to the power n minus r, b to the power r. So this is called the general term. Is it clear? T r plus 1 is equal to NCR a to the power n minus r and b to the power r. If I want to find the 5th term, okay, for example, if I want to find 5th term, T5 is equal to n c, what is the value of r? 1 less than this. 5 is can be written as 4 plus 1, right? R will be 4, NC4 a to the power n minus 4 and b to the power 4. So this will be the 4th term. Sorry, this will be the 5th term. Is it clear? So this is about the general term. Now last one concept is there, that is finding the middle terms. Then we'll be solving the problems. Okay? Middle term, even this is a very important concept. Just I'll explain this concept. After that, in the next session, we'll solve the problems based on this. Okay? See here, middle term, you know how to find the middle term. Here, the value of n. For example, listen carefully. N is even. For example, n is even. Okay? Now, how many terms will be there in this expansion? One more than that, right? So, if it is n is even, the number of terms will be odd. One more than this, that means n plus 1. Odd number of terms will be there, getting odd terms, right? Agree for this? See, for example, if I say a plus b whole to the power 8. Now n is even, the number of terms will be 1 more than that. That means 9. The number of terms will be odd. Right? So remember, if n is even, the number of terms will be odd. To find the middle term is given by odd, we cannot divide by 2. So it will be n plus 1 is odd. So plus 1 divided by 2. So this will be the middle. Is it clear? Suppose n is even, the number of terms will be odd. Since the number of terms are odd, only one middle term will be there. To find the middle term, it will be n plus 1 divided by 2. If it is n is even. Now, if n is odd, for example, n is odd, so n is odd, so the number of terms will be even. 1 more than that means terms will be even. Since the number of terms are even, how many middle terms will be there? Obviously 2, right? So the number of terms are even, the number of 2 middle terms will be there. So it will be n by 2 and n by 2 plus 1th term. So these are called the middle terms. Is it clear? I hope you understood this. Just let me take one example. See, for example, if I write x plus y whole to the power 10. Okay, this is one example. X plus y whole to the power 10. How many terms will be there? This is index is 10. Obviously, the number of terms will be 11. Right? Number of terms are 11. How to find the middle term? 11 is odd. Right? 11 is odd. So, only one middle term will be there. So, that means 11 plus 1 divided by 2. It will be 12 by 2 will be the 6th. Yes? So, this is n plus 1 by 2. Now, if it is x plus y whole to the power 13. Okay? Since this is index is 13, the number of terms will be 14. Agreed? Number of terms are 14. Since 14 is an even number, there will be 2 middle terms. Right? What are the middle terms? N by 2 and n by 2 plus 2. So 14 by 2, it will be 7th term and the 8th. These are the 2 middle. Is it clear? So this is about the middle. So in this session, the main thing you have studied about the binomial expansion. A plus b whole to the power n, and here the power of a will be decreasing and power of b will be increasing. Remember that, and the values will be nc0, nc1, nc2, nc3 like this it will go, and a minus b whole to the power n. Whenever you get negative sign, alternatively positive and negative signs. Then 1 plus x whole to the power n, that expansion is very important, and expansion of 2 to the power n. Then the general term is given by, this is very important, tr plus 1 is equal to ncr, a to the power n minus r and b to the power r. So this is a very important one. And next is the middle terms. In that middle terms, if it is n is even, the number of terms will be odd. If n is odd, then the number of terms will be even. Remember, the number of terms will be always 1 more than the index. I hope you understood this concept. Okay, in the next session, we'll solve some problems based on this. Thank you.